Okay, here we go. We are on 1.2 guided notes. Okay, so real numbers. Remember your real number system. Your real number system is made up of rational and irrational numbers, and you can use the letter R instead of having to write the words every time. That's why these letters are on the side, so that when we're naming the sets, you can use R for real numbers. Rational numbers are going to be all your whole numbers, integers, and fractions and decimals. Okay? So this would be like -2, -1.5, 0, 1, 2.5. Don't forget that it will also have square roots in there. Perfect squares. What's the square root of 9? 3. That's why it's in this set. So this set is negatives, 0, positive, and then fractions, 2.5, and decimals, 1.5. Remember that it's terminating decimals, 1.5. You could also have repeating decimals. So you do have terminating decimals and repeating decimals in this set. In the next set of irrational numbers, remember in the irrational set, you're going to have non-terminating and non-repeating. They are decimals that go on forever. They don't have a pattern. They're decimals that go on forever. Well, hey, guess what? Repeating decimals go on forever. But repeating decimals have a pattern. It's 0.333333. That's the pattern. So here you don't have any terminating decimals. Terminating means to stop, like 1.5. That terminates. Repeating decimals has a pattern. So what kind of numbers are decimals that go on forever that have no pattern then? There's always one that you always think of all the time. Pi. Pi is a decimal number that goes on forever with no pattern. And then, of course, you have your non-perfect squares. Square root of 5 is not a perfect square. The square root of 7. Is the square root of 9 a perfect square? Yes. It's a perfect square because it's 3 times 3. So it doesn't belong in this set then. And then, of course, you have your integers, negative numbers. What? Oh, there it is. Negative numbers, 0, and positive numbers. Whole numbers is 0 to infinity. Natural numbers, how you naturally started counting. Remember for Algebra 1, how did you naturally start counting? You said 1, 2, 3. You didn't start with 0. That's the whole set. That's why it's called the whole set, because it includes 0. 0 debt, awesome. 0 money, not so much. But it means something. It's a real number. Okay, so when you're talking about your sets, you're going to use these letters that are here instead of having to write the words every time. So looking at -11/3. Where would a -11/3? Where's the first set that it belongs? Starting at the bottom. Let's go like this first. Let's go like this. Sometimes looking at this way, real numbers are broken up into 2 sets, and that is the rational and the irrational. I'm a visual person. I'd much rather look at this picture because I can write it all down without having to look at any notes. If I was taking a quiz and there was no notes, I could just make this little diagram. They're all real numbers. This year, you will get into imaginary numbers, which would be a set next to this one, just like you have a set next to rational. It'd be over here. Another whole box over here, imaginary numbers. But for now, we're on the real number system. Then everything is under rational. You have integers. And then you have the whole numbers and the natural numbers. That is your real number system that you have been learning for a very long time. So this is the picture I like to think about, even though I can look at my definitions up top, or I can look for the letter that I need. Where's the first place? I like to start at the bottom. Where's the first place that you're going to see -11/3? Are you going to see that in the natural numbers? Are you going to see it in the whole numbers? No, it's not a whole number. It's a fraction. Are you going to see it in the integers? Do we have any fractions in the integers? I know the negative is in the integers, but are there any fractions in the integers? No, so it's got to be the negative and the fraction. What's the first set that you will see a negative fraction? It starts here then. Rationals and goes up to reals. So we're going to say rationals and reals. Is the square root of 25 a perfect square? What is it? That's what we're looking for then. We're looking for the number 5. Is 5 in the natural numbers? Yes. So we know where it starts. That means it goes all the way up through to real numbers. Once you find where it starts, it's going to go all. This set is within these sets. So we've got the natural numbers, we've got the whole numbers, the integers, and then the rationals, Q, and the real. You cannot be rational and irrational at the same time. So be careful if you're reading this going up through. You are either one or the other. You can't be sane and insane in the same instant. Okay, I can feel perfectly sane 1 minute and then feel a little insane the next, but not at the same time. It's one or the other. Same thing here. You can only be one or the other. Okay, go ahead and do 0. Find where it starts and write down whatever you need to. Where does 0 start? What's the first set? So there you go. Whole, integers, rational, and real, all the way up through. Whole, integers, rational, and real. How about problem D? Does anybody know how to say that? Very good. Tenths, hundredths, thousandths, 10,000ths. So that's 192 and 5 10,000ths. That means I can say 192 and 5 10,000ths. That means that I can change this decimal into a fraction. That tells me that it has a pattern and I can do it. So it's definitely not going to be here in the irrationals with a decimal that you can't make a fraction out of it. All right, so where's the first place that you see a decimal? Where's the first place you see a decimal or a fraction? All right, so it starts in the rationals and continues to the real. What's your strategy for E? Any strategies? Perfect. It's a perfect square. Every time you see a perfect square, you simplify it. That means I'm looking at 6/9. Okay, your ninths are always repeating. So this is a fraction that has a repeating decimal. Where's the first place that you see rationals? And of course, always the reals this time. What about pi? Irrational, which is I, and of course it is real. Okay, how about problem G? 4.3 repeating. Where's the first place you see a repeating decimal? Rationals are repeating. And of course, it is a real number. They're all real. Okay, do the last one. H, 0 and -0 and 2/10. Integers do not have decimals in them. We can't say integers. It has to fit both sets. Your real number properties in the homework, you'll have to name them. Commutative property, we have of addition and multiplication. A plus B is the same thing as B plus A. A times B is the same thing as B times A. In your own words, what would you say the commutative property was about? Just looking at the left and to the right, looking at the left and to the right. In your own words, what would you say is happening? They're flipping, they're switching. This is about order. What about the associative property? What do you think the root word in associative is? Associate. You associate in groups. Students are always associating in groups, sometimes called cliques, right? Associate. How do you associate? With parentheses. Okay, notice that the order hasn't changed. ABC, ABC. That's really what I always look for first. The order is the same, but what's happened? The parentheses are on A and B, and then you add C. We know PEMDAS from 1.1, parentheses mean something. You have to do parentheses first, right? So order does matter, but with the associative property, we can switch the parentheses to the last part and we'll still get the same answer. Same thing with multiplying. It's about grouping. How are they grouping with the parentheses? You really got to make sure just because you see parentheses doesn't make it associative. If you looked at inverse or distributive property, they also have parentheses on those as well. So be careful. It's really about the grouping. I love identity. Identity, it is what it is. When I look in the mirror, I'm Michelle. When I walk away, I'm still Michelle. It's not changing. Well, the same thing with numbers. What would I do to a number to get back that number? I would add 0. It should be A plus 0 equals A. I will add 0 to get back my number when it's addition, and I will multiply by 1 to get back what I started with. It's the identity. It doesn't change. It stays the same. So for adding, we add 0. For multiplication, we multiply by 1, and we get back what we started with. Inverse means to do the opposite of A. The opposite of A is negative A, and I will get a 0. The inverse operation is used when we're solving equations. If x is being added by 2, then I subtract 2. 2, negative 2. So for adding, undoing equations with addition, we do the opposite. What about when we're undoing multiplying or dividing? We use the inverse. That's what these properties are used for, the inverse. Distributive property is a big property that's used. A times B is AB plus A times C. All right, so here we go. We did this in algebra, simplifying. We're going to start with the distributive property. What's 8 times 3A? And 8 times negative B. That's it. We're getting rid of those parentheses. I can't add any A's and B's together over here. They're both in parentheses, and we need to get rid of them before we can simplify. Then we have 4 times 2B, which is a positive 8B. And then we have 4 times negative A, which is a negative 4A. Now we're just looking for like terms. There's no equal sign. I'm not shifting across an equal sign. I am just trying to simplify whatever I have here. Exactly. 24A minus 4A would be 20A. I have like terms here. What's negative 8B plus 8B? Correct. They cancel each other, right? I had $8. I spent $8. I got nada. All right, like terms on problem B. We got 40S and 11S, 40, 50, 1S. I hate S's. And then we have 18T, negative 5T, 18 minus 5, almost. All right, and then we're going to practice working with fractions and decimals. Just practicing them, trying to get used to them. So we've got 1/5. You can just multiply straight across. Don't do anything to the 1/5 because you've got to use it 1, 2, 3, 4 times. Multiply straight across. It's a fraction. I made 4J a fraction. 1 times 4J is 4J. 5 times 1 is 5. There, I've multiplied it together. Multiplying straight across. Plus, now we have 1/5 times 2K. Multiply straight across. Yeah, so we get 2K over 5 minus 6J over 1. Multiply straight across. 6J over 5 plus. That's it. The only thing you have left to check is one thing. What do I need to check before I say I'm done? 2 things. What do I need to check? Huh? Combining terms. Do we have any terms that we can combine together? What do we have? Very good. Notice how I keep my signs inside of my squares or circles. It helps to remind me if I'm adding the same sign or different signs. What do we get for 4J fifths minus 6J fifths? Excellent. 2J fifths. And then we have a K and an H term, so nothing to do with that. 2K fifths. Positive 3H fifths. Okay, that was one thing you had to do. Look for like terms. How do I check my final answer now? you make sure that you're reduced. I have 2/5. 2 is prime, 5 is prime, 2 is 5. These are prime numbers, 3 and 5. Nothing reduces. That would be the final step. Can I reduce my fraction? Okay, problem D. Same thing. Make 12 a fraction this time and multiply straight across. 12 times a over 3 is going to be 12 times a over 1 times 3. Minus. Good. 12b over 4. Are these like terms? Do they both have the same variable? No, so I can't combine them. But what do I need to check? Reduce. What's 12 divided by 3? So 12a divided by 3 is 4a minus 12b divided by 4 is, whoops, what am I doing? That's a b. Distributive property. 8 times 2.4. Just go off to the side. 2.4 times 8. 4 times 8 is 32. 8 times 2 is 16 plus the 3. And then I need to figure out how many decimal places. 1. I got 1 right here. The 8 is a whole number, so 1 decimal place. 19.2 R. And then go off to the side. Positive times a negative. I'm going to take care of that sign as a negative. And then 3.1 times 8. (24.8s). Okay, do the next two. Don't holler out answers though. Let everybody get a chance to try. Six times 5 is 30. Carry the 3. 6 times 1 is 6. Plus the 3 I carried is 9. And I see only 1 decimal place total in the problem. So what am I going to, if I get 9.0, what do you think I'm going to write down? 9, right? 9.0 is just 9. Minus 9R. And then 2.4 times 6. 6 times 4 is 24. Carry the 2. 6 times 2 is 12. Plus the 2 I carried. And there's 1 decimal place, so 14.4. S. Negative times a positive is a negative. And then 14.4 S. They're both negative. They're the same sign. So we add them up and keep the same sign. They're both negatives. Means you add them up and keep the same sign. You do line up decimals when you're adding and subtracting. Negative 39.2 S. Then we have our R's, 19.2 minus 9. Can I do that in my head? 19 take away 9. 19 take away 9. 19.2 minus 9 is going to be a positive 10.2. 10.2 R. And that's as far as we can go on this.